Is the screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So, do you have any question regarding this double integration that much you have completed by Professor Lokikanta there?
No, sir.
Not at
No
all.
problem.
So,
Sir,
we are going to discuss that little bit.
Excuse me, sir.
As yes,
Sir, what are the differences between iterated integral, double integral, and repeated integral?
uh, these are the actual double integration is helpful to find out the volume as well as the surface area, mainly the volume. Iterated integral also give you the volume, but the way we are computing, that is different. And another one you are saying double integration, iterated integral, repeated integral. Repeated integral, I think iterated integral and repeated integral is same. All three gives you the same, but the matter is the different way we are computing. In case of your double integration, we have some of your single integration by which we can compute the double integration, such as if you apply the Green's theorem, you can find out the double integration, you can convert the double integration to a single integration. If you have the double integration, if you want to compute over that region directly, then that we can compute by your considering different strip along different axes. And iterated integral is separate. If you can separate it, then you can find out that integration, such as if you have the integration something like that, the integration that is integration over d f dx dy. So if we can write it down separately, that integration, and again integration and some f1x and f2y, then dx and dy, and we have the separate limit also, and it is some constant a to b and c to d. Then we have integration a to b f1 dx, we can compute integration c to d f2 dy, we can compute that. We can separate this integration and then we can compute. So that is your repeated integral. If we consider the iterated integral, then we can have that double integration can also be computed by your integration a to b integration c to d f dx dy. We can compute it by changing the changing the limit from c to d, and integration a to b f dy dx. That is your repeated integral. First we can compute that with respect to x, then we can compute with respect to y. So for that, it's not that always or all the time we are getting some constant. It may possible that we can get some functions as your limit. Okay, so depending on that, means along which axis you are considering the strip initially, depending on that we have to integrate the function. So what we compute in general, if we have this axis and we have the surface, surface is this, and then if you consider any curve on this surface, then after so by fixing some value of x, if you consider this one is your x-axis, this one is your y-axis, this one is your z-axis. So if you fixed x, so we are going to find out the area of this portion, then and that can be computed from your some value of your means range for your y. So that is from say y equals to, in this case actually it is 0 to some value of your y, that is 0 to some function, or we can say here some constant, say d, or we can say in general c to d. You have f of xy integrating with respect to y. So then the value we are getting, so this integration is called your inner integration. And then after we take that as we move this slice from the range of your the terminal of a to b, that means from this point to this point. So then we consider that integration, we are going to consider that integration for some value a to b, integration that you have now, the value you are getting in terms of your function of x, that can be a function of x, that is f of xy dy whole into dx. So that is the your repeated integral. Then similarly we can do it for your y-axis also. If you fixed your on y-axis, then we consider a slice along that x-axis. Then we find out the area under the curve that we know for your definite integral, what we compute. So after computing that definite integral, and then we can move that slice from your this point to this point, that will give you the another repeated
This
integral.
will give us the volume of this figure.
Yes, that will give you the volume of this figure. Okay,
So then
that
what is
is
the role of z-axis?
z-axis gives you the volume, means height of the surface. If you are going to understand this one, then you have to know this figure as a whole.
But when we are going to compute the volume, there is nothing about dz like that.
No, z, we are not considering that z. Without considering that z, we are I'm showing you this figure. This will clear you that why we are not considering that z. So if you consider that the base can be your rectangle, it can be triangle, it can be circle or anything else. So we consider here for simplicity one circle, there's triangle is there. Then we divide this base point by some parallel strip. This is supposed to be your y-axis. This is it. So we consider the surface is something like that. I mean, draw this one. Is this? So what we have done, the base, what you have, we have divided it into the small portion. Okay, so that in that any box are of the same length. If you just recall about your area under the curve, that is the definite integral, that is the single integration. But we do that, we just divide that the length of your x into the small portion. So like that, in this case, instead of your one length, we have the two length, we have divided into the rectangle. So that can be your dy, this portion is your dy, and this portion is your dx. Your dx. So that small portion gives you the area. So if you consider the surface on this,
Please again repeat this part.
I'm coming. So what you have a surface under which you have to find out the volume that creates on the xy plane. So what we have the base of that surface. So that base we are going to divide into the small portions. So whenever we are going to divide, we just take the equal division. So along y-axis we are taking the equal divisions, along x-axis we are taking the equal divisions, and for that we are getting the small square. Okay, so it's better to draw here so that you come to know. If you consider in 2 dimension, you have a graph like this, you have this area under the curve, so A to B. What we do, we just consider a small strip on it, which gives us that dx. And this is the curve y equals to f of x. We're just extending this idea. The same, if you are doing that, the single integration, if you are doing the multiple integration, you are ultimately taking the infinite sum. So that small portion, now you have that the length your dy, length your dx. We have that small portion has its height on the surface. So that height could be connected by this point. That could be connected by this point. That could be connected by this point. That could be connected by this point. So that is the small strip we are considering, or the rectangle, or we can say parallelepiped. So that will give you the volume of this portion. So that z is actually working here. That is your z. That is the height. Now, if you make this small dx and dy, that is dy is tends to 0, dx is tends to 0. So that comes to a point ultimately. Okay, then we take the summation for this dx and dy. That ultimately gives you the total integration. So what we are doing here is that the volume del v, it comes to your z into del a. Del a means your dx and dy. Okay, that we can write down also, z into del x and del y. So if you consider that divide it into the small portion, so sorry, that is your del vi. So the height will goes changes, because if you are taking the different points, so the heights it's not maybe, it must be changed. And because of that change of your height, so at a different point we are getting the different values, that is your z of I. But your dx and dy will remain same, that is your del x and del y. And this z of I is ultimately your f of x and y, del x, del y. Now, what you are saying that what is the role of your z-axis? Now, if you have the surface on your xz plane, if you have the surface on your yz plane, then of course we are considering the different thing. That is then that time we consider the height will be on your, if you have the surface on your xz plane, of course you need to make change. Surface is on your xz plane, then the height will come from your y-axis. So that means dx and dy, dz will come up. Okay, so yi will come up dependent on your x and z. Okay. So that is the thing. Now we are going to sum it up. So if you take the summation for all I, that will give you all the points. It varies over the surface. So since the surface will not always to be your uniform, that is the flat surface, it is your curved surface. So heights are going to changes, and those heights could be computed with the help of your different points. At the point xi and yi, you could find out the surface area. You could reach at the surfaces. So that will give you the total volume of this under this surface on the xy plane.
Here
That sum
we are
is,
representing z as a function of x and y.
and that the surface we are going to represent here as a function of x and y. Yes.
Okay.
Now some of the properties are there, means as you can see that it comes so that's why this figure will give you much more clear. If you consider the area under the curve, so that now instead of this surface, if you consider only one line on the surface, that will give you an curve. So this gives you the area under the curve. So since that is your area under the curve, that is your definite integral from c to d f x y dy. We consider that x is your fixed. because you have taken that x is fixed. So that comes to a definite integral. So since that is your definite integral, so all the properties of your single integration are being held here, such as your linearity property. If both the integrations are your same, then we can separate them, such as if you have that integration over d f plus g dx dy, it comes to that integration over df plus integration over dg. This will hold. We have also the constant multiplication. If you multiply the constant term, integration over d c into f dx dy, that comes to c into integration over d here f dx dy. Or you mute yourself. If we have that the two regions on which you are doing that integration, if
So you're not audible.
You are muted.
so if you're going to do the integration over a region and we can split those two regions for the symmetry, so we can split it. So that split can be done. Suppose D is a surface, D is a surface, and split it into two surfaces, they say R and S, then we can take that integration over D, and that should R and S should not be overlapping. Then only we can do this, because just as of your same single integration, in case of you have to exclude some point where the function may not be your continuous, so that time we can take the integration a to c to b. Or sometimes if we do the break, then the function has its some properties through which we can evaluate the integration much more easier. So like that way, here also we can separate the regions if they are not overlapping. Double integration over r f dx dy plus double integration over s f dx dy. We can do this. And if the function is your continuous, we also have the inequality holds for your, if you take that mod of integration over d f dx dy.
Sir, can you show the previous slide once again? Okay, sir, got it.
Sir, only symmetrical surfaces can be split into two parts, or any surface we can split.
You're muted once again. Sir, I think you're muted.
Sir, you are muted. Sir,
You are muted.
So it's not that every time we have to take the symmetric. No. What I am saying that not that symmetricness on which we can split it. Your surface will not always be bounded by a rectangle, or it will be bounded by your some other thing. It may be your curved surface. Suppose you have the curved surface, something like this one, then up to this portion we can take a symmetricness, so we can separate this total region D by your R and S. Okay, so that to make the region is your symmetric, so that we can integrate the function over that region, and we can what the thing is, we can take the limits easily from one curve to the another curve. Yes, you are saying something.
Sir, I can split the function when the function is must be continuous.
No, I am not splitting the function. I am splitting the region actually. We are
So
not
it is the
taking the
projection of the figure on xy plane.
Can the region be unbound?
no. Region will not be unbound. Region must be bounded. Otherwise, how do you do that integration? That is the definite integral we are considering. That must be bounded. Okay, that side you may have that axis. So you may have the axis. That's why you are saying. So it is bounded, of course, over which you are taking that integration. Someone saying some
Sir,
another
what is
question?
E here?
What is?
E here. Projection of figure on xy plane.
No. We are not taking the projection on xy plane. It's a surface on which we are taking that integration. Okay, that surface we are showing here from the upper part. If you see the surface, then it will look like this one. Okay, you may consider
Okay.
that this one is the projection on your xy plane or any plane figure, maybe xz or somewhere else. But it's not exactly the projection we are taking. It has its base point, base curve. So if you don't, it's not being changed. Such as if you have what we have considered here, it may be your changed, maybe the curved surface if you draw in such a way. But in this case, we are considering this one is triangle and the upper portion is also the triangle. It may be your curve. If it is curved, then what will happen? The z points, the heights will go changes. Okay. So whenever if it is not your symmetric, suppose this portion is your parabola like this, So we can make this division into two portions. One is your R, another is your S. So for S you can do that integration. For R we can do that integration. Then we can sum it up if they are not overlapping.
Okay.
Sir,
Yes.
sir, in the slide in which you showed the inequality, can you please show it again? Yes, sir. In this slide, sir told us that anytime f goes negative, we have to take it as minus of minus f to compute the volume.
Yes, we compute the volume. Actually, negativity comes because when the most of the portion of your volume comes to the below the x-axis. That's where the negativity comes. Now, to make that your positive, we have to take the changes that you are saying. Sir has said to you. Okay, that's
Sir, then
correct.
essentially, anytime we calculate the volume, we are calculating the right hand side of this inequality.
Yes. Sir has said about the Fubini's theorem.
No, sir.
No, sir.
No, sir.
Okay. So it's I'm not writing. Sir maybe discuss on that one. So I am saying only the statement. The statement is very simple. If you have a function which is your continuous and it is defined over the interval, means rectangular region over a region bounded by two interval, then the double integration can be evaluated with the help of your iterated integral. Okay. So we can have this one. So I will give you the details on that. So that is f x y dx dy is equal to integration that d is supposed to be a region bounded by your AB cross CD. Then we can have that is A to B and A to B C to D f dx dy, or which is also same A to B C to dx dy. Sir will also consider discuss on the remarks on this theorem. So we are not going to discuss on these. We are going to solve some of the problems. If we the simple problems. Your first class on leaving over.
So the next line, so dx dy,
dy yes sir.
so dy.
So dy dx.
Right, so
But why don't-
so if we are going to find out the volume from one volume. your the plane equals to x minus 2y. X plus y. Take it to y equals to y equals to 1. So I think we could solve this one very easily. Z it will be given. You need to be find out first the we draw this figure. Then we could think of so that is your bounded by the axis. If you consider this one is your y, this one is your x. So x plus y equals to 1. So the line passes through like this. We have considered this one is your positive axis. X plus y equals to 1. That is your base point, and then the surface do you have that z equals to x minus 2y. So for that, what we are going to do, we just integrate for that y equals to, if we take that region from that is 0, so that is x equals to 0 to this line by fixing y. So the range is x equals to 0 on this, and this one is x equals to 1 minus y. X equals to 1 minus y. That is the range for your x. Now range for your y is, it will moves from your 0 to 1. So y has its range from 0 to 1. Move from this point to this point. So therefore now it is easier to integrate. You can integrate, that is integration your 0 to 1, integration 0 to 1 minus y, that is your z is your x minus 2y, dy dx.
So from where the range of y has come?
Range of y is coming from here. That is your, if you put that the axis is your 0. Now since we are taking that on your y axis, so x is your 0. So if x is 0, this comes to y equals to 1. So that is 0 to 1. Is it? So that is this. Now if you are going to consider the some different strip, then we can have in different way. We are taking by fixing your x on your x, we are getting this region. So for that we have the range of your y change from your y equals to 0 to 1 minus x. So that is that time the range is y equals to 0 to y equals to 1 minus x, and again by this one, that is x equals to 0 to x equals to 1, that moves on for 0 less than equals to 1. So either of the process you can evaluate, that will give you the answer, that is integration 0 to 1, that is for your x, integration 0 to 1 minus x, then x minus 2y dy will be first, and then dx. So both the integrations gives you the same value, and then you can evaluate. That's a simple integration. I'm not going to solve this one. Come to another problem that
1 by 6.
yes
1 by 6.
1 by 6. Okay, very good. So it's got that answer already. It's 1 by 6. Another problem.
Here it can be negative.
Here.
So it is negative -1 by 6.
It comes to negative.
Yes, sir. It is negative, sir.
What's the idea?
Yes, sir.
Cannot be negative.
So some it's negative. So we have to make negative for that value.
It's
So we have
-1
to
by 6, sir.
break the part.
If we take z x minus 2y, then I don't think it is a minus. I also took z as x plus y minus
But
1.
it comes negative also. We are not making it negative.
0 to 1 क्यों है dx సపోజ్ తీసుకుంటే 0 నుంచి 1 వరకు మూవ్ అవుతుంది ఇప్పుడు 0 నుంచి x వరకు మూవ్ అవుతా ఉంటా అంటే y అనేది x
Sir, -1 by 6.
Okay. So we consider another integration. 0 to 2 integration. In this case, your the region is bounded by 2 curve. That is your y equals to x square, and another one is y equals to x. The surface is given by your x cube dy dx. So we can change also the order. So if you draw this is your y equals to x square, so you can have equation of your parabola. So y equals to x square means and the line y equals to x. So that is y equals to x. That is your y equals to x square. So if we in this case we are taking that y equals to x square to y equals to x, that is this stream. But if we are going to change, we can make it change it in terms of your x-axis also. So that you have initially this one. Now we are going to make it want to make it change, so that we say this. So that iterated integral, I think you have solved many when you have done the area under the curve. So in this case, we are considering directly that of the single integration, single variable. We are considering the both multiple variables. Sorry. Okay. So if you're going to make changes here also you have that y equals to, this is your x. So that remains y equals to x equals to y. X equals to y.
Sir,
And yeah.
sir, here the outer limit should be 0 to 1.
Outer limit should be 0 to 1. That's right.
Otherwise it will become negative.
0 to 1. And this side the limit of your x will be x equals to under root y. Okay. So we can make changes here, that which one is favorable. That is integration 0 to 1, integration x equals to y to x equals to root y, and then you have x cube dx dy.
1 by 30, sir.
Okay, that's the thing we can do. Similarly, if we are going to solve another problem.
Sir,
So
in
if we take
problem
2
number
instead of
1,
1, then what is the difference?
Yes.
In previous problem, if we take 2 instead of 1, then what is the problem? Region will not be bounded.
No, 2 will not become, because 2 is your outside of that region. The point we are considering 2 here, it goes up. Yes. How you're getting, that is your you're taking that the range of your x, that is your 0 to 1. 1 is there, we are considering 2, so that is outside the region. So that portion, the
Sir,
region is not bounded by the curve.
Sir, how I
sir, why
check
you
the
change the
point 2 is
limits, sir?
outside of the boundary?
Sir, the limits, why you
The
have
point
changed it, sir?
you just intersect the curve, because you have that y equals to x square and y equals to x. So the point of intersection, you could
Sir,
be find it out over that plane. X square minus x equals to 0, that gives you that x equals to 1 and 0, 1 and 0. Therefrom you can find it out.
sir,
Yes.
sir, why can't you write the lower limit as x equal to root y and upper limit as x equal to y here in the second case?
Actually that should have to be, I have written wrong here.
Yes, sir.
That should have to be. This portion is your this is
Sir, x equal to y to x equal to root y, no, sir.
Yes, sir. Earlier it was correct.
Yes, sir.
x equals to y to x equals to, okay,
Root
we are
y.
moving from right.
Yes, sir. Yes, sir.
Yes,
I
sir.
have made it wrong. Yes.
Horizontal area we are taking, na? So root 2 will be.
We are taking from this direction. Okay. This type of problems I think you have solved, and still now none of the theory has been over, so we could not go beyond of that. So we find out the last one, that is the find the volume. And
We have a single class till now.
yes.
Sir, we have not
Bound.
solved this type of problems before. I'm saying that.
You have solved this type of problem whenever you are going to find out the area under the curve, area bounded by two curve over the plane. We have just been extended this thing from area to volume. We have included that portion of your z only, nothing else. You have done this type of problem, that is area bounded by the curve, something. This type of.
Yes, sir. Yes, sir. Single integration.
That's a single integration. You have not done the multiple integral. So what is the difference? We are taking only one more variable and the height of that, the surface we are considering. Instead of 2 dimension, we are considering the 3 dimension. That is the extension part.
Sir, in the previous problem number 1, we got a negative answer. So, is it correct? Like,
this is correct. We are considering this one means the surface is going beyond of your x-axis. Means the z-axis we are considering that maybe comes to the negative side. That's why we are getting that the volume.
So how the problem number 2 implies the volume?
How?
So problem number 2 implies a volume.
I couldn't understand. How could he? Problem number 2.
So is it a volume?
What is exactly the volume?
The computed value after the integration, what you are getting, that is the computed value. This is the surface we are considering. Z equals to x cube only. Okay, and now according to that surface, whose base point is this one, we are going to compute this one. Okay.
Sir?
Yes.
Sir, in two-dimensional integration, the integral must be in the area, and the three-dimensional integration, the integration change will be the volume.
Yes. For the simple cases, we are getting it to be your volume, because if you go through this one, that gives you the volume ultimately. If you consider instead of your plane curve, or rather than this one is clear, instead of your plane curve, if you now move it from a point 0 to some extent, z0 to z1, then that creates a surface. Okay, so for that surface we are getting a volume. It creates your 3-dimensional figure, so that must gives you a volume instead of your area. Even though if you move that slice from one point to another point, one plane to another plane, so that creates a volume.
Okay, sir. Okay.
So these two figures actually give you the total idea what we are doing and what it represents by. Okay, we solve one more problem. That's also easy. So find the volume bounded by the planes. X equals to 0, y equals to 0, z equals to 0, and x plus z equals to 4. That you need to be computed. Okay. That represents what? If you go for this,
Plane.
no, these all three. So you have this x equals to 0. It's a plane yz. That is z. That is y. That is your x. So x equals to 0, yz plane. Y equals to 0,
XZ plane.
xz plane. Z equals to 0,
XY
xy
plane.
plane. And this is a
Right,
plane. If you made it into your intercept form, that
4
will
by
give
2.
you
Yes,
x
sir.
by 2
2
plus y
comma
by
4 comma
4
4.
plus z by 4 equals to
Yes,
1.
sir.
So we can x by 2, so it's smaller.
2 comma
This
2.
is, yes. So that gives you a tetrahedron.
Yes, sir.
So we have to find out the volume of the tetrahedron. So
Z
you
by
create, yes. So what that z is, in this case you have to find out that z equals to the outer
4
surface.
minus y.
Yes, 4 minus
Y minus 2x.
minus 2x. That is your z. What are the regions that will move from your xy plane to that surface? So therefore you have to make that 4 minus y minus 2x equals to 0, and another one is your y equals to 0.
Okay.
So we can we can find out that y equals to 2x minus 4. And similarly, you can take that x equals to 0 to x, you can find out in terms of your y. So that is the range for your y. Once we are getting the range for your y, we can get the range for your x, that is
Please
starts from.
explain how did you find the range?
You can see that the base, we have considered that the z axis is your the function f of xy. So if it be so, we have to consider the base is your xy plane. So for base is your xy plane, so that time you have the equation of the line will be 4 minus y minus 2x equals to 0 over this line, over this plane. So to find out the range, we consider that x is fixed. So if x is fixed, y has its range from this one. Y has its range from your 0 to 2x minus 4. That is this line.
Sir,
Now
y
we are
comes out to be 4 minus 2x plus.
Yes, sir. 4 minus 2x.
4
Y
minus
equals.
2x. Yes.
So we can directly get it from intercept form also, no?
Yes, you can also get it from there. Then you can move it for your x-axis. That is from your x equals to 0 to x equals to, you can make it 4 minus 2x equals to 0. That is x equals to 2.
2 minus y by 2.
So y is equal to 4 would be the
Y equals to
4 minus z.
4 minus 2x. Okay, so the integration then comes to x for your 0 to 2. Y has its range from y equals to 0 to what you have, x minus 4 minus 2x. 4 minus 2x. Z